The last question we want to answer in regards to this question is down here. It says this: at what time will the projectile be 90 meters above the ground? At what time will the projectile be 90 meters above the ground? Well, we're given some information and we're asked to find some information. At what time? We're looking for time. Will the projectile be 90 meters above the ground? We're given a height. So we're given that h is equal to 90. And time is what we're looking for. We don't know what time is. So what we want to do is we want to plug 90 in for h and solve for t. What this ends up looking like is we plug 90 in for h, so that's 90 is equal to negative 4.9, right, just a little different, 4.9 times t squared plus 52 times t plus 12. And here's the equation that we need to solve for t. It's a quadratic equation. Because of the numbers that I see, I'm not going to attempt to factor it. I cannot solve by the square root property, and completing the square would be relatively difficult. So I'm going to go straight to the quadratic formula. But in order to use the quadratic formula, we remember that we have to have our equation set equal to 0. So I'm going to start by subtracting 90 from both sides of my equation. And that ends up giving me 0 is equal to negative 4.9 times t squared plus 52 times t, and that would end up being minus 78. So we've got our equation here set equal to 0. I'm going to identify the a, b, and c right here real quick. So my a value is equal to negative 4.9. My b value is equal to 52. And my c value is equal to negative 78. Well, we know that the quadratic formula tells us that if we have a quadratic set equal to 0, then our variable, in this case t, is equal to negative b plus and minus the square root of b squared minus 4ac, all divided by 2 times a. So we want to go ahead and plug our a, b, and c values into this, and it produces t is equal to negative 52 plus and minus the square root. Let's see, that's going to be 52 squared minus 4 times a, which is negative 4.9, times c, which is negative 78. Let's extend that square root, and all of this is divided by 2 times negative 4.9. Okay. What I'm going to do is I'm going to go ahead and simplify everything underneath the square root symbol. So go in here, well, with the square root symbol. So I'm going to go square root, let me turn this on. I'm going to go square root of 52 squared minus 4 times negative 4.9 times negative 78. Enter. I get 35.13. 35.13. So t is equal to negative 52 plus and minus 35.13, all divided by 2 times negative 4.9 is negative 9.8. Okay. At this point, we can split this up into 2 separate equations. I'm going to bring my calculator over here. And we are going to end up doing negative 52, so we're going to do the addition part first. So negative 52 plus 35.13. Get an answer for that, and we're going to divide that by negative 9.8. We end up with 1.72. So t is equal to 1.72, or now we need to do subtraction. So it's going to be negative 52 minus 35.13, and divide that by negative 9.8. We end up with an 8.89. 8.89. So we end up with two answers. T is equal to 1.72 or T is equal to 8.89. The question is, which one of these is the correct answer? In fact, both are the correct answer because there's two locations in which our projectile is 90 meters in the air. On the way up, so here's our cliff, on the way up and on the way down. If 90 meters is right here, there are two locations, right, at which we are 90 meters in the air, on the way up and on the way down, as we've said. So both solutions for T are correct. The projectile is 90 meters in the air at 1.72 seconds and at 8.89 seconds.